Hello, Math 95 students. Looking at section 9.4 now. Section 9.4 is about how to solve quadratic equations using something called the square root method. All right, so let's take this example to introduce us to this topic. Let's say we had x squared minus 9 equals 0. And we actually already know a method to solve this that we learned in chapter 8, which is a part of factoring that we learned. And that is that we can factor this expression using what's called difference of squares factoring. It factors as x plus 3 and x minus 3. And we get that the answers are, when we set this equal to 0, we get negative 3. When we set this equal to 0, we get positive 3. So we get plus or minus 3 as our answers, or 3 and negative 3, if you want to say it that way. But there's another way to solve it that we need to learn, because not all of these kinds of expressions are factorable that way. But we'll go ahead and learn how to do this one with the square root method. All you do is you're getting x by itself. You're doing algebra that you already know how to do to get x by itself. So if we're getting x by itself, that means we got to get rid of this minus 9 first. To get rid of that minus 9, we do the opposite of that, which means I'm going to add 9 to both sides, and that cancels that out. So now I've got x squared equals 9. So now to get x by itself, I need to get rid of this. I need to get rid of this exponent. Get rid of that squared exponent. How do I get rid of a squared exponent? I have to do the opposite of a squared exponent. The opposite of an exponent is a root. So to get rid of a squared exponent, I will use a square root. And whatever I do to one side, I do to the other side. So that square root cancels out that squared exponent, and it leaves me with x by itself. Now, the square root of 9, whenever I take the square root of both sides, I've got to think to myself, the answer to this question is what, when you square it, will give you 9? And there's two answers. When you square 3, you get 9. When you square negative 3, you also get 9. So the way that we handle that is that we say, whenever you take the square root of both sides, you have to put plus or minus in front of that result. So the square root of 9 is 3. The principal square root of 9 is 3. But whenever we take the square root of both sides of an equation, we have to put plus or minus in front of that result to get the full answer. So x equals plus or minus 3 is the answer. And it's the same thing I got when I used factoring. So let's use that same method to try to solve these three examples here. So if I do this first one, x squared equals 25, I could solve it by factoring by moving the 25 over and doing the difference of squares, but we want to do the square root method in order to solve these. So I'm going to get rid of that squared exponent, getting x by itself, get rid of the squared exponent by taking the square root of both sides. That leaves me with x on the left-hand side, and on the right-hand side, the square root of 25 is 5, but don't forget to put what? Don't forget to put plus or minus in front of that result. So my answer is x equals plus or minus 5. For number 2, x squared equals 3. Again, this one wouldn't be able to be solved by factoring, because when you got x squared minus 3 on the left side, 3 is not a perfect square. So you couldn't really factor it using the difference of squares as we've learned it before. So to solve this, we're going to do the square root method, where we do the square root of both sides. Square root both sides. On the left side, we get x. Why did it do that? On the left side, we get x. And on the right side, the square root of 3 doesn't have a perfect square root, and it can't be broken down to anything simpler. So I've just got to leave it. I've got to leave it as the square root of 3. But I still have to put something in front of it. Can you guess what? I still have to put plus or minus in front of it, just like I did over on this side. But see, the square root of 25, that just simplifies down to 5, but the square root of 3 won't simplify, so I just leave it as it is, the square root of 3. Okay, you could get it as a decimal if you had a calculator, and you could get an estimated answer that way, but we can leave it as the square root of 3, and that actually leaves it as an exact answer, because the square root of 3 is an exact answer, whereas a decimal, the square root of 3 as a decimal, it goes on forever. You'd have to round it off somewhere, so it would be an estimated answer. All right, let's look at number 3. All right, to solve number 3, I'm going to try to get rid of that square exponent by doing a square root on both sides. It cancels out the squared exponent, and it leaves me with x on the left-hand side. And on the right-hand side, what have I got? I have a negative number under that radical. So again, for now, when we have a negative under the radical, we're just going to say that it's not a real solution. Or you might say no real solution. Okay, for now, that's what we're going to say. Later, we'll learn how to put it as an imaginary solution. All right, look at this problem. X squared minus 24 equals 0. I've got to get x by itself, so the first thing I'm going to do is add 24 to get rid of that. Cancels that out, so I get x squared equals 24. Then I got to get rid of the squared exponent by doing the square root of both sides. So x equals plus or minus, but the square root of 24, this is how this example is a little different, it's not a perfect square, but it can be simplified. How does 24 break down? How about 4 times 6? And then 2 times 2. And 2 times 3. So we got a pair of 2's. So I'm going to bring a 2 out. But that 2 doesn't have a partner that's like it, and that 3 doesn't have a partner that's like it. So they both have to stay underneath the radical. So underneath the radical, I have that 2 and that 3 that come back together to make a 6. So my answer is x equals plus or minus 2 square root of 6. Positive and negative 2 square root of 6. All right, next example. Okay, 3x squared minus 4 equals 3. I've got to get the x by itself. The first thing I'll do is get rid of that minus 4 by adding 4 to both sides. That cancels that out. So that gives me 3x squared equals 7, because 3 plus 4 is 7. Divide. Now I've got to get rid of that 3. How do I get rid of that 3? The 3 is multiplying with the x, so I've got to divide it to get rid of it. So that cancels that out. So I divide by 3 on both sides. X squared equals 7/3. Now, get rid of the squared exponent by taking the square root of both sides. So x equals plus or minus the square root of 7/3. But remember, this is what we learned in the last section, you can't have a radical on the bottom, and right now there's a bottom number that's under that radical. So what we're going to do is we're going to simplify that by splitting it up into the square root of 7 over the square root of 3, and then get rid of the square root of 3 on the bottom by multiplying it with itself. So now we get x equals plus or minus the square root of 7 times 3, both under the radical, so it's the square root of 21 on the top. And the square root of 3 times the square root of 3 is the square root of 9, which is just what? Which is just 3 on the bottom. Remember, the square root of something times the square root of that same something is that something. So that's my answer to that problem. Next example. This time we have x plus 4 parentheses squared equals 36. So now I can't get rid of the plus 4 yet because it's inside of it is grouped with the x in the parentheses with the squared on the parentheses. So the first thing I have to do here is get rid of the squared. I've got to get rid of that squared so that I can ungroup that x plus 4. I can get rid of that parentheses. So how do I get rid of that squared exponent? I take the square root of both sides. So I've got x plus 4 equals plus or minus, what's the square root of 36? It's 6. Now I will subtract 4 from both sides. So that x now equals negative 4 plus or minus 6. Well, that turns into two different answers. And since both of these numbers can just combine together, that's going to be negative 4 plus 6 and negative 4 minus 6. So x equals negative 4 plus 6, which is 2, and x equals negative 4 minus 6, which is negative 10. So 2 and negative 10 are my answers for x there. That came from negative 4 plus 6 and negative 4 minus 6. Negative 4 plus or minus 6 is 2 and negative 10. All right, let's look at this example. So here again, the x minus 7 is grouped. I can't get rid of the minus 7 until I get rid of the grouping, which is the squared exponent on top of this parenthesis. So I've got to take the square root of both sides to get rid of that squared exponent. That gives me x minus 7 equals plus or minus Now the square root of 50 will break down. 2 times 25, 5 times 5. So I've got a 5 on the outside, 2 on the inside. Okay, now I can get rid of the minus 7 by adding 7 to both sides. So I've got x equals 7. I put the 7 first, then plus or minus 5 root 2. So I just put the 7 in front of that plus or minus 5 root 2, and it's 7 plus or minus 5 root 2. So 7 plus 5 root 2 is an answer, and 7 minus 5 root 2 is another answer. But this is how you can write it as a shorter way to write that. Next example. Okay, the first thing I will do here, again, the 3 and the minus 4 are in a group in the parentheses, so I got to get rid of that parentheses by doing the square root of both sides. I'm going to do the square root of both sides here. That gives me 3w minus 4 equals the square root of 36 is just plus or minus 6. Okay, now I'm going to get rid of the minus 4 by adding 4. And you remember what we write here? We say 3w equals, we put the 4 first, 4 plus or minus 6. Okay, then we will get rid of the 3 by dividing both sides by 3. That gives me w equals 4 plus or minus 6 over 3. Now I can go ahead and combine the 4 and the 6. They can just combine together. So that becomes 4 plus 6 over 3 and 4 minus 6 over 3, so that the 4 and the 6 can just combine together. So that gives me 4 plus 6, that's 10 over 3. I know that's sloppy. And 4 minus 6 is negative 2 over 3. So 10 thirds and negative 2 thirds are my answers to that one. All right, I like this next example, although you probably won't. We've got px plus q squared equals k. So you're not going to like it probably because it doesn't have numbers. But I like this because we're solving for x, and it forces us to think about what we're doing with these letters for us to have to think about just what is involved in these steps without just thinking about the numbers. So the first thing we have to do is take the square root of both sides to get rid of that squared exponent. Again, we're trying to get x by itself. So now I've got px plus q equals the square root of k. I've just got to leave it as the square root of k. I can't do anything with it, but I do have to put plus or minus in front of that whenever I take the square root of both sides. Next, what do I get rid of? I get rid of the plus q, so I subtract q from both sides. So now I've got px equals, I put the minus q in front. I say negative q plus or minus the square root of k. Then I divide both sides by the p to get rid of the p. So that's my answer. X equals negative q plus or minus the square root of k all over p. And that's my answer. All right. Now, next example, this example says, find the x-intercepts of the parabola f of x equals blah, blah, blah. This sounds different, but it's not different. Find the x-intercepts means you're finding where it crosses the x-axis, which means the y-coordinate every time we're on the x-axis is 0. So we're substituting in 0 for y to solve for that. So where the f of x is, that's going to become 0 to solve this. So it's the same kind of problem. I'm still solving it the same way I did. I'm going to put 0 here. 0 equals negative 2 x minus 7 squared plus 20. All right, so if you wanted to put this as equals 0 on the right side, if you wanted to put equals 0 over here, that's fine. Instead of over on the left, that's totally fine. Doesn't matter. So I'm going to get rid of that plus 20 first by subtracting 20 from both sides. That gives me 0 equals negative 2 times x minus 7. I'm sorry, that gives me negative 20 equals negative 2 times x minus 7 squared. Then I have to get rid of this negative 2. How do I get rid of that? Well, it's multiplying here, so I have to divide it. So that gives me 10 equals x minus 7 squared. Make that a little neater. Then I will take the square root of both sides to get rid of that squared exponent. That gives me, I got to put plus or minus in front of that square root of 10. Plus or minus the square root of 10 equals x minus 7. I can't break down the square root of 10. If I could, I would, but it won't break down. It just breaks down to 2 times 5, so neither one of them have a partner, so it won't break down. Next, I add 7 to both sides, and I put the 7 in front, so it's 7 plus or minus the square root of 10, and that's what is equal to x. All right, y'all remember that if we have a negative under the radical, then it's a non-real answer. Well, now we're going to talk about how we can actually still find a meaningful answer to those kinds of questions by using. And it's unfortunate that it got called imaginary back in the day, because it makes students think that it's not real. Why the heck should we deal with imaginary things? This is not fairy tales. It's not. Imaginary is it's just an unfortunate word. It's not imaginary. It's not make-believe. It's not a fairy tale. It is actually a useful answer. These things are used for in electrical engineering types of applications and other interesting applications. I wish they had called them lateral units or something, because they're not on this real number axis plane. But think of a different, if we just gave it a different axis, call it the lateral axis or an imaginary axis, then we could plot those numbers there. There was a time in history when it was thought that x plus 3 equals 1 was a nonsensical kind of problem, because if you subtract 3 from both sides, then what? You can't take away a bigger number from a smaller number, but then they came up with something called negative numbers, right? So x equals -2. And that just means that instead of having $2, we owe $2, or we're going 2 units to the left or something like that. So it's still a useful thing, right? Negative numbers, we don't think of those as imaginary. Well, it's kind of the same thing here. It's just unfortunate that they were called imaginary. So here's how we deal with it. We define the square root of -1. We give that a definition. That's a triple bar equal sign. It means is defined as I, or I will be defined as the square root of -1. Or we could say -1, I squared is defined as -1, or I squared is the number which when you take the square root of it, you get I, or the square root of -1. All right, so it's called the imaginary unit. Here's what that allows us to do. Let's say we had the square root of -4. Well, we all know the square root of 4 is 2. But we can break the -4 down to a +4 and a -1. And now the +4 we can get the square root of that. It's 2. So a 2 comes out of this, but the -1 doesn't have a partner, so we have to leave the -1 underneath the radical. But we've already said that the square root of -1, we define that as I, so that this is just 2I. And we can always do that. Okay, here's the definition. If you have this, if you have the square root of -p, you can just make it be the square root of +p with an I with it. Put an I with it. So next example, we're trying to write these square roots of the square root with a negative underneath the radical. Instead of just saying not real, now we're going to put it with an I. So the square root of -49, just treat that as if it's the square root of 49, but just put an I with it. Okay. So what's the square root of 49? It's just 7, and then just put an I with it, and that's how you do it. Next, negative square root of -24. Well, just put an I with it and just make it be a +24. The negative sign on the outside is still there, so I'm going to put the I there. And now it's just going to be a +24. All right. In general, if you've got if you still got a radical, the I goes in front of the radical. If the radical breaks down just to a regular number as a perfect square, then put the I after that regular whole number. Okay, so notice I put 7i here, but here I've got the I in front of the square root of 24. Okay, now 24 breaks down to, let's say, it doesn't matter how you do it, 2 times 12, 2 times 6, 2 times 3. So a pair of 2's, but with an extra 2 and an extra 3 left over under the radical. So so I've got a 2 coming out here. So I've got -2, because of that negative sign there, I square root, what's under the radical? The 2 and the 3 come back together under the radical to make 6. So notice that 2 goes in front of the I, but that goes in front of the square root of 6. That's that simplified answer. Okay. A complex number is a number of the form a plus bi. So it's got a real part, which is the a, and it's got an imaginary part, which is the bi. And that's called a complex number because, again, it's complex because it has a real part and an imaginary part. Let's use that new skill to now be able to solve these kinds of equations. All right, y squared equals -9. We get the y by itself by getting rid of the squared exponent by taking the square root of both sides. All right, at the beginning of this little unit, we would have said, well, the answer is not real, no real solution. But now we're going to give it a different kind of solution. We're going to give it an imaginary solution. So this becomes y equals plus or minus the square root of -9. Just treat it just like it's a positive 9. What's the square root of positive 9? 3. But we put an I with it. Plus or minus 3i. Okay. X squared equals -12. Take the square root of both sides. X equals plus or minus. Okay, treat it just like it's a positive 12. If it was a positive 12, we would break it down. 6 times 2, 2 times 3. I've got a pair of 2's. Got a pair of 2's right there with an extra 3. So the 2 comes out. The 3 stays underneath the radical, but I've got to put an I with it, and the I goes in front of the radical. So plus or minus 2i root 3. If you put plus or minus 2 root 3 and then an I afterwards, I probably wouldn't count it wrong, but it is not the conventional way to write it. All right, we're solving this example 11 here. X plus 3 squared equals -28. Get rid of the squared exponent first by taking the square root of both sides. That gives me x plus 3 equals plus or minus the square root of -28. Now let's break that 28 down just as if it was a positive 28. Square root of 28 breaks down to 7 times 4, and the 4 is 2 times 2. So a 2 comes out and the 7 stays underneath. So I've got x plus 3 equals plus or minus 2. Don't forget your I, square root 7. Then I get the x completely by itself by getting rid of that plus 3 by subtracting 3 from both sides. So x equals, the -3 is going to come first. -3 plus or minus 2i root 7. And that is our final example in section 9.4. Good luck on that assignment. I'll see you again in 9.6.